Hi everybody. In this video, we're going to look at trigonometric equations. There's two parts. In the first part, we're going to show this equation can be written in this form. And then in part B, we're going to use what we've done here to solve the original equation between the range of 0 and pi over 2. So do you want to give question A a go yourself? You can pause the video and come back when you're ready. So welcome back if you had a go. With questions like this, the first thing we need to do is to write the cot and the sec in terms of sine and cos. We know the cot squared 2 theta can be written as cos squared 2 theta over sine squared 2 theta. And sec theta, we know is 1 over cos theta. So now we can substitute each of these into the original equation. Now the next step would be to simplify this bracket by giving this 7 a common denominator with the sine squared 2 theta. So now we've simplified the bracket. We have a mixture of 1 theta and 2 theta. So what we can do is move this division of cos theta over to the left-hand side and use the double angle formulae to simplify this. So can you see that the 2 sine theta cos theta simplifies to make the sine 2 theta? And now in this term, we'll cancel with the squared. So we're left with a division of sine 2 theta. And we can move this now over to the right-hand side. So now we've got all 2 thetas. The problem we have now is we have a mixture of cos squared and sine squared. And we can use the Pythagorean identity to write this in terms of sine squared. So we have 3 multiplied by 1 minus sine squared. Now we can expand out these brackets. And then we'll collect these like terms, the sine squared 2 theta terms. And we can move this 13 sine 2 theta over to the left-hand side, so it all equals 0. And now, if we divide both sides by the sine squared, this would become negative 10, which is in this term here. So we get the 3 over sine squared 2 theta. This term becomes negative 10. And this becomes negative 13 over sine 2 theta. And finally, we know that the sine squared 2 theta is the same as cosec squared 2 theta, and the same for this. So we get 3 cosec squared 2 theta minus the 13 cosec theta 2 theta minus the 10 will equal 0. And this is what we were asked to show here. So that's part A. Do you want to try question B using what we've done here to solve this equation? You can pause the video and come back when you're ready. Okay, so how did you get on with that? If we begin by letting x equals cosec 2 theta, then we can write this as a simple quadratic. We'll have 3x squared minus 13x minus 10 will equal 0. And we can factorize this, so we've got 3x plus 2 multiplied by x minus 5. So you can see that cosec 2 theta, which is x, will be negative 2/3 and positive 5. But now we need to write each of these back in terms of sine 2 theta. So we'll have 1 over sine 2 theta will equal the negative 2 over 3. We'll move this over to the right-hand side and the 3 over to the left-hand side. So we get 3 is equal to negative 2 sine 2 theta. We'll divide both sides by the negative 2. And we know the sine of 2 theta will have a range between 1 and negative 1. So this solution is not valid. So our other solution must come from cosec 2 theta equals 5. So 1 over sine 2 theta will equal 5. Therefore, sine 2 theta will equal 1/5. And if we take the arc sine of both sides, 2 theta in radians will be the arc sine of 1/5. So 2 theta will equal 0.2014 radians. Now we've been asked to solve this in terms of theta, so we need to change our domain to match with 2 theta. So we're given between 0 and pi over 2. If we double this, we get 2 theta is between 0 and pi. Then we can use our cast diagram to find the other solution. First solution is at 0.2014 radians. And we know this is positive, so we're looking at the second quadrant. And this will be pi minus 0.2014. So 2 theta will have solutions 0.2014 and 2.941. If we divide both by 2, theta will be 0.101 to 3 decimal places and 1.47 to 3 dp. Okay?